Now everything is ready, so we can make some measurements. Um, Let me explain the essence of this lab. So what exactly we're going to do. So what we're going to do is we're going to move this cart to the photo gate. So we're going to release the cart somewhere from here, and then the cart will move through this photo gate as well as this one, so we can get the velocity of the cart at these two locations. So we know the mass of the cart, or we can measure the mass of the cart, and we have the velocities of the photo gate at two locations. So we can find the kinetic energy of the cart at these two locations, here and here. So obviously the kinetic energy here going to be much higher compared to the kinetic energy here, because cart is accelerating downward, the velocity increases. With that, kinetic energy going to be increasing with time. So if you know the kinetic energy here and here, then you can calculate the kinetic energy difference between these 2 points. That's one part of the lab. The second part is you're going to calculate the work done by each force acting on the cart. So what are the forces acting on the cart? One is weight, mass times gravity. The other force is normal force acting on the cart, and there could be some friction force. And from the result of this experiment, you can get some idea about the friction force, whether it is a significant or can you neglect that friction force. So when cart is moving from here to here, each force will do a work on the cart. So then you can calculate the work done by each force. You will realize that the work done by the normal force is 0, because the direction of the displacement and the direction of the normal force, they are perpendicular. The only force that going to do a work is the gravity. So you're going to find the work done by the gravity when the cart is moving from here to here, and then you can compare that with the kinetic energy change between these 2 points. Okay, so I'm going to get my first data point. To get my first data point, the separation between the photo gates need to be 90 centimeters. So let's measure the separation. So this is 90 centimeter mark, coincide with the left side of the photo gate. Now I'm going to go to the other side, to the other photo gate, without moving the ruler, and you can see I have to adjust the position of the photo gate little bit. So I'm going to adjust that. So I adjust that. Now the separation between the photo gate is exactly 90 centimeters. So now hit record here and keep the cart just above the first photo gate and let it go. Then the photo gate will measure the velocities of the cart, or the speed of the cart at each location. Let it go and make sure you catch the card before it leave the table. Okay, so I have two data points. Point 35 is the velocity at photo gate 1, and 0.61 is the velocity of the card at photo gate 2. Now the next thing you're going to do is you're going to change the separation between the photo gate to 80 centimeters, and again measure the velocities of the card at these 2 points. Similarly, you can change the separation between the photo gate to 70 centimeters, 60 centimeters, 50 centimeters, and 40 centimeters, and each time you can measure the velocity of the velocities of the card at these two positions. So altogether you're going to get 12 different velocities, 6 here and 6 here. So in your data table you will see those velocities, then you can do the analysis. Then you can do the